You know, we spend so much of our lives on video calls these days, but have you ever just stopped and wondered, how does this stuff actually work? Well, in this explainer, we're going to peel back the curtain on the system design that powers apps like Google Meet and Zoom. And trust me, it's way more interesting than you might think. So it really all boils down to this one big question. How in the world can an app connect 50, even 100 people at once without the whole thing just crashing and burning? It feels like magic, but it's not. It's just some really, really clever engineering. And we're going to solve that mystery together. Okay, so to understand how a massive 50-person call works, we've got to start small. I mean, really small. We're talking about the simplest possible situation, a call between just two people. This is the absolute foundation for everything else. First things first, let's get on the same page with some lingo. In the video call world, you're not just a user, you're a peer. It's a simple term, but it's important. Anyone in the call, you, me, your boss, we're all peers. Got it? Cool. Now, when it's just the two of us on a call, the system is beautiful and simple. We use something called WebRTC to create a direct peer-to-peer connection. You'll hear that called P2P. Think of it just like a direct phone line. My video goes straight to you, your video comes straight to me. There's no server in the middle doing anything, it's just us. And this P2P model is amazing, but only for two people. It's super fast, it's direct, and because there's no server doing any work, it's basically free for the company running the app. But it has one gigantic show-stopping problem. The whole thing falls apart the second a third person tries to join the call. And here we go. This is where our nice, clean, simple system starts to get really, really messy. What happens when our little two-person chat needs to become a three-person meeting? Well, this is the first problem engineers had to solve. So the first idea they had was, hey, let's just expand on that P2P idea. They called it a mesh architecture. The rule was simple. Every single person on the call has to create a direct P2P connection with every other person on the call. You can probably already see how this is going to get out of hand. It becomes a tangled web of connections real fast. And this is where the math just kills the idea. With three people, it's kind of clunky, but maybe doable. But look at this. By the time you have just 5 people, you need 10 separate direct connections. That means your computer has to send your video stream out 4 times and receive 4 different streams back. Can you even imagine trying to do that with 20 people? No way. So yeah, it becomes crystal clear super fast that the mesh approach is a total non-starter for group calls. It just doesn't scale. It puts a ridiculous amount of work on your poor computer, and with all those connections flying around, it's incredibly unstable and a complete nightmare to fix when something breaks. Okay, so the engineers went back to the drawing board. They knew that to fix this tangled mess, they needed to introduce a new player to the game, a powerful central server that could act as a coordinator, a director for this whole chaotic show. And that brings us to something called an MCU, which stands for Multipoint Control Unit. And honestly, the best way to picture an MCU is to think of a director in a TV studio control room. They're taking in all the different camera feeds and mixing them together to decide what the final broadcast is going to look like. The process makes a lot of sense. Instead of everyone connecting to each other, now every single peer sends their one video stream up to this central MCU server. Then the server does all the heavy lifting. It takes all those videos, decodes them, and literally mixes them together into one single combined video stream. Then it sends that one stream back out to everybody. But, and you knew there was a but coming, right? This solution creates a massive new problem. As this quote says, taking a bunch of separate video streams and mixing them into one on the fly in real time, that is an incredibly difficult and processor-intensive job. And you can just see it right here. The CPU load on an MCU server is astronomical. It's through the roof. This makes the whole system crazy expensive to run, it can introduce lag, and worst of all, it takes away all control from you. You just get sent one pre-mixed video. You can't change a thing. So the high cost and the total lack of flexibility with the MCU, well, that led to the next, and for now, the final evolution in how video calls are built. This is the real secret sauce behind the apps that we all use every single day. Let's talk about the smarter server. It's called an SFU, or Selective Forwarding Unit. And look, if the MCU was a TV director, the SFU is more like a super smart, super fast postal sorting center. It doesn't open your mail, it doesn't read it or change it, it just receives all the packages and routes them to the right destination as fast as possible. So here's the core difference right here. The MCU's job is to mix everything together. It does a ton of processing. The SFU's job is just to forward. It does almost no processing at all. It just acts as a traffic cop, a central hub that receives streams and sends them right back out. So think about this from your computer's point of view. In an SFU call, you send your one stream up to the server, but you don't get one big combined stream back. Nope, what you get back is a separate, individual stream for every single other person on the call. The server is just forwarding them all to you. And you might be asking, okay, so what? Why is that so much better? Well, this is the magic. This is why you can do all the stuff you totally take for granted. Because your computer is getting all those separate streams, it has total control. That's what lets you pin your boss's video to make it bigger. It's why you can change from a grid view to a speaker view. You can even mute that one person who's typing really loud because your app just chooses to ignore their audio stream. It's all happening on your device. So let's bring it all home. We've gone on quite the engineering journey here, right? From a simple direct line between two people, all the way to the powerful, flexible systems that connect millions of us every single day. This table pretty much says it all, doesn't it? The mesh P2P model had no server, but it couldn't scale at all. The MCU could scale, but it was expensive and gave you zero flexibility. And then there's the SFU, which gives us the best of both worlds. It's super scalable because the server's job is easy, and it gives your computer maximum flexibility to do what it wants. And that's the big takeaway. The Selective Forwarding Unit, the SFU, that's the elegant and efficient design that powers basically every major video platform you use today. It's the answer to our original mystery. So we've pretty much cracked the problem of connecting dozens of people in real time. The SFU has made global video calls a stable, everyday thing. Which leaves us with one final thought to chew on. What's the next barrier? What's the next great challenge that engineers will have to solve to bring us all even closer together?